So here we are discussing problem number D, add to neighbor and remove from Codeforce Round number 690 division 3. Time limit is 3 seconds per test case and memory limit is 256 megabytes. The input and output are standard. So first let's read the problem statement. Polycarp was given an array of n integers. He can perform the following operations with the array no more than n times. Polycarp selects the index I and adds the value ai to one of the choice of its neighbor. More formally, Polycarp adds the value of ai to ai minus 1 or to ai plus 1. Adding it, Polycarp removes the ith element from the array. During this step, the length of array is decreased by 1. Okay, it's fine. So we have understood the operations. What Polycarp do that suppose here we have 31662. Then Polycarp will remove 3 and 1 and replace them by 4 as here. Okay, fine. So basically, in more formal words, Polycarp remove two adjacent elements and put one single element there, which is the sum of those two adjacent elements. Okay. Polycarp could stop performing operations at any time. Polycarp wondered how many minimum operations he would need to perform to make all the elements of A equal. Fine. So we have 3000 test cases here, and in average, and for every test case we are provided n numbers. So the first line of the test case is the length of the array, that is the n numbers which are provided, and the second line we have the n numbers as the input, and these numbers vary from 1 to 10 to the power 5. It is guaranteed that the sum of n over all test cases does not exceed 3000. Fine. So one of the here is that Polycarp deletes two adjacent elements and replaces them by their sum. So the length of, let's suppose here we have an array 1 2 2 1 3. Okay. So what Polycarp will do that will delete both these elements and replace them by 3. Again, so will delete both these elements and replace them by 3. And this element before it's 3 already. It's 3 already. So she will not do anything with this. So she gets 3. So she gets 333. Okay. So what one observation is here that you can see that 213 213 213. So the sum of all the elements in the initial array and the final array is equal. Okay, fine. Now suppose that Polycarp performs k operation. So the number of elements after that will be n minus k. Simple. So we know already that since Polycarp performs in k operations and after that the number of elements in the array will be n minus k, all the elements of the array are already equal. So each element of the array will equal to s divided by n minus k. Okay, fine. So we have figured out what will be each of the element of the array. So now we have to check that how many operations will be there. So suppose this is an array. Okay. A1. So here the 2 points that are important to observe, that we only add adjacent elements. Means we cannot add a1 and a3, we can only add a1 and a2 and then delete both of them and replace them by a1 plus a2. So basically one of the Another way of interpreting this very problem is that we want to split this very array into the array of the longest length possible, such that each of them has equal sum. So suppose that this is, so we replace a1 plus a2, we replace, suppose that we are having 1 2 3 4 elements after all, and so we are adding 2 times. Okay, suppose, so what we are doing here, if we have split it by 2, then here we have 3 as sum, 3 as sum. So what Polycarp will do, that see, at first, means what we have to do, that at first we assume that we are having p operations. Okay, so after k operations, what we have a target, that we want to make all the elements of the array equal. So the number of elements in the array are all equal to s divided by n minus k. How it comes, that after k operations we'll have n minus k elements on all, and all the elements in the array are equal, so all the element, and the sum is also constant, so all the elements are finally s divided by n minus k. But for this to be an integer, s should be divided by n minus k. S is not divided by n minus k, then k is not a true value, means we cannot have k operations. Fine. But if s is divided by n minus k, then we'll have another layer of check. What we'll do, that we'll take x equal to so at first, suppose a few element, so what we'll do, that we'll start adding from here. Okay, a1 plus a2. After so if at a particular time, the sum of these first suppose m elements come equal to x, then it's okay, we can continue further. For example, suppose here in this code, that after n minus k operations, we have k elements left. This is the array, this is the sum of the array, and this is the length of the array. So if the sum of the array is equal to k, which is the number of elements left after n minus k operations, if it is not divisible by k, then it will be a false, means we cannot have k operations. But if it is divisible by k, then what we'll do, that we'll get an element p which is equal to sum divided by k, but means that will, if k is the number of operations after which we can make all the elements of the array equal, then each element of the array will be equal to p, which is equal to sum by k. Okay, now we'll have a loop. And there is another declaration, current, I have written it as short, cur equal to 0. We'll keep adding the elements of the array to cur. If cur sometimes become p, then it means that here, that suppose it sums up to p, this is also equal to p, this is also equal to p, then here we can have k operations on the array. Okay, but if cur if cur is less than p, then we'll keep adding the elements of the array to it. But if cur becomes greater than p, then it means that k is not a proper value, so we'll return false in this case. Okay, so this is a solution for the problem number D here. I have provided the code in the description. Thank you for watching. If you enjoyed this video, please like, share and subscribe my channel. Please, if you have any doubts or if you want to say something, Please leave it in the comment box below. Thank you.